Hello, and welcome to the Six Figure Developer Podcast, the podcast where we talk about new and exciting technologies, professional development, clean code, career advancement, and more. I'm John Calloway.
I'm Clayton Hunt. With us today is Matthew Renze. Matthew is a data science consultant, author, and international public speaker. He has over 2 decades of professional experience working with tech startups to Fortune 500 companies. His current focus is teaching others data science, code craftsmanship, and agile software development. Welcome, Matthew.
Thank you for having me.
So why don't you tell us how you got started in the industry and give us a little bit of insight there.
So I started out as a software developer over 2 decades ago now, and all of the projects that I had been working on in my career at that point in time were essentially big data or data science projects before there really was a term for data science. I mean, we were shipping hard drives through the mail and stuff to try, getting our data base updated. Back then we didn't have the internet connections that we have today. So I kind of went as far as I could with my software development career and decided that I needed to go back to college in order to take my career to the next level. So I went back and I studied data science and machine learning. Well, technically it was computer science and artificial intelligence. But as I got further into my career after college, I realized that there was this emerging trend that was being referred to as data science. And it essentially matched perfectly what I'd been doing my entire career so far. It was always, I was always the person that was doing a data analysis rather than just trusting my gut and, hoping that I made the right decision. And so I started doing consulting in the data science space. And this has eventually grown into more artificial intelligence consulting. So it's data-driven AI is probably the best way to describe it, where we're essentially using data in order to train models and then solve business problems with machine learning, artificial intelligence, and data science. And that's pretty much what I do today. I teach others how to make better decisions with data, and then automate those decision-making processes through artificial intelligence and machine learning.
That's crazy. So you've really pretty much been in data science and AI your entire career then.
Yeah, I've always seemed to be on kind of the cutting edge of whatever the next big wave was, whether that was by choice or by accident or kind of a hybrid of both. But it seems that I've always been in the right place at the right time and followed that path to take me to the next big thing.
So in order to level set and make sure that we're all speaking the same language and getting a general vocabulary together, what is artificial intelligence, or what can we classify as artificial intelligence?
Well, a lot of people have different definitions of artificial intelligence. The academic definition is essentially any machine that acts rationally in response to its environment, that can perceive its environment and then make a decision or choose an action that maximizes some goal that it's trying to achieve. Whereas the general public typically thinks of AI more as anything that a human can currently do that a computer currently can't do, which really isn't the best definition since that's constantly sliding. Essentially, the example approach is probably one of the easiest ways for people to understand what AI is and what it isn't. And that's, essentially a computer that can play chess. That's clearly a form of artificial intelligence. Navigation software on your smartphone, it's clearly a form of artificial intelligence. Your robot vacuum cleaner, essentially figuring out how to optimally vacuum your floor. Once again, artificial intelligence. And then we've got the ideas, the futuristic stuff like what we refer to as general AI, the sentient robots like R2-D2 and stuff like that. And that's a ways down the road, at least a few decades until we can get to that form of like general, more flexible intelligence. But where we currently are right now is with artificial narrow intelligence, this set of AI tools that can solve a very narrow set of problems and in many cases solve them quite well.
Now, I remember when I was younger that there was all kinds of talk of AI and crazy sci-fi movies in the 90s and even earlier than that with like Space Odyssey and whatnot. But it all just kind of disappeared. Is the current phase of AI that we're going through more or less a fad? Is it going to disappear, or is this something that's not a fad?
Well, artificial intelligence, most people don't realize this, dates all the way back to the 1950s. There was an original AI conference, I believe it was in Stanford, where some of the the main figures in AI got together to discuss this topic of intelligent machines. And after that, artificial intelligence essentially went through a couple phases of hype and then like booms and then busts afterwards. So we saw what we refer to as the first AI winter somewhere in the 1970s until the early 80s, or late 70s, 70s until the early 80s, where essentially funding and research for artificial intelligence almost dried up because the expectations and the hype got so big that the practical applications in reality just couldn't match the expectations. So people lost interest. It was a giant bubble. And then we saw the same thing happen again in the 1980s during the era of what we call expert systems. These machines that could do inductive reasoning and essentially understand kind of chain rules of logic. Without going too much further into explaining how they work, once again, we saw a whole bunch of hype about what they looked like they'd be able to do, but the economics just didn't make sense. They were very fragile. They would produce all sorts of wild errors given novel inputs and stuff. And we kind of saw a collapse of the industry again with that second AI winter. But then somewhere around the early 2000s, there were a few companies and pioneers in the area of AI, like Google and some researchers too, that started to apply machine learning in rather creative ways or ways that started to make sense. In addition, we also saw, the amount of data we had available to train these algorithms increase. We also saw the amount of compute power go up, and then the algorithms got better, and we had a much more disciplined approach to artificial intelligence, this new data science approach. And that led to the new boom that we're seeing right now. Whether we're actually about to enter a new AI winter, it's difficult to say, but there are some pretty interesting trends that seem to indicate that we may be on a more stable kind of increase to eventually having artificial general intelligence a few decades from now. But the future is extremely difficult to predict, especially with things like this. So I would say it's quite likely we're on a relatively stable path right now, but I would not be surprised if 5 years from now we're also talking about, hey, remember how awesome AI looked? Well, yeah, now we're in a slump again.
So you've mentioned the term general a couple times. What is the difference between my robotic vacuum cleaner or my Amazon Echo and something like HAL 9000 or C3PO?
Well, most people would classify the distinction as either artificial narrow intelligence or artificial general intelligence. So narrow AI is a type of artificial intelligence that can solve a very narrow set of problems. We have the tools to solve a lot of very narrow domains of knowledge right now. So like your vacuum, essentially figuring out how to vacuum your floor, or voice recognition, image classification, all of these very narrow tasks that we can solve with AI, and we can piece these things together to solve more complex problems. But it's not flexible or adaptable intelligence like we see with artificial general intelligence, where the machine is essentially capable of adapting to whatever you throw at it, and it can essentially apply knowledge from one domain across to another domain in very flexible ways. So essentially, a domestic robot that could essentially vacuum your floor for you and make your dinner and fold your laundry. Something that could essentially do all of these tasks with one AI or one brain, essentially. We haven't reached that level yet, and that's what's still quite a ways off.
You say quite a ways. How far are we off from having, can't remember her name exactly, Susie or whatever from the Jetsons?
Well, once again, very difficult to predict, but there are a lot of experts that think we're going to hit it sometime right around 2050. Some experts think it's going to be earlier than that. Some think it'll be later, and some people say it's never going to happen. But I would say, based on everything I've seen, it's probably going to be sometime around 2050 before we have a general artificial intelligence powerful enough and flexible enough to essentially just do whatever task you ask it to do. If a human could do it, the AI will most likely be able to do it, and most likely better than any human.
Yeah, excuse me. Yeah, it seems like combining a couple of different at-home tasks, cooking and cleaning, is quite a bit different than like the robot dog that I've seen at the labs where people try to push it over and it can get up and do different obstacles. So it seems like there's a big distinction between the at-home AI tasks versus the truly autonomous, almost thinking, feeling, learning, growing.
And I think it largely has to do with the technologies we have available, plus some other things. The amount of data we have to train these models, the amount of compute power we have to improve the models over time, and the algorithms that we have available in order to train these models. So, like right now, if you were trying to train, an AI to detect whether it's a coffee mug or whether it's a glass, so it squeezes with the right amount of pressure, we would essentially just feed it a bunch of images of coffee mugs and the right tensile strength you need to use in order to pick up the coffee mug versus the piece of the glass. And that's a very narrow task, and the way we solve that's very different than essentially just telling a robot, hey, I need you to go fold my laundry, and it's never done it before. It could look up a video of how it's done and essentially infer from seeing the video how one goes about folding laundry, and to figure that out without a large amount of training. And that's the direction we're going with artificial intelligence in the future, this idea of self-supervised learning, or one-shot tasks where you just show it how to do something once and it essentially can figure it out based on all of the existing knowledge that it currently has. But there are some pretty good examples of that in very limited or constrained environments. Like right now we have a model called GPT-3, which is kind of the most cutting edge natural language processing or generation model we currently have. And it's pretty impressive in the sense that you can essentially ask it to do something in text, and then and show it like one example of what you want. Like, say, for example, you want to translate this sentence from Spanish to English. You essentially just say, translate the sentence from Spanish to English. You show it one example of what that translation should look like. And then you just start giving it other sentences and it'll do the translation, which that's really impressive. Like I weren't even able to do that just a few years ago. But the fact that we have a language model so robust and so powerful that it can actually understand the command that you're asking and then produce the results without having to learn that specific task individually is really impressive. In fact, if you guys get a chance, you should check out, it's a natural language bash prompt where you can essentially either type in bash commands or you type what you want in English, and it will actually produce what it thinks is most likely what you're trying to execute. And then you just say yes, no, or modify the command, and then it's essentially running it for you.
So you could just type like, show me all the files in this directory, and then it should LS for you.
Yep, it absolutely does that.
That is awesome.
Yep.
So you mentioned like going out and finding models where we get to the artificial intelligence that knows enough to go and get the models. But I know that we've had some discussions before about the ethical issues of the models being fed into like a machine learning algorithm or something like that. Are there, and now I suppose are there continued, and what are the ethical issues facing us today with artificial intelligence?
There's actually quite a lot of potential ethical issues, not just in the future, but right now. For example, we have, you guys have probably seen the deep fakes where we have essentially an algorithm generating what looks like, President Barack Obama saying something that he never actually said, or from a previous speech, and simulating the output. There's a potential to use that in pretty nefarious ways if someone chose to use it. And we've actually seen it being used with voice, essentially faking a person's voice in order to, I think it was for embezzlement or something like that. They pretended to be a CEO of a company, used his voice and released, the funds into a bank account or something. So, I mean, we have to be really careful with how this technology is being used. And that's where somebody's maliciously doing it. Whereas there's a lot of accidental problems with AI as well. So as the old saying goes, garbage in, garbage out. If you feed a model, if you feed the training algorithm a bunch of biased data, it's going to produce a biased model. And if you feed it a bunch of metrics that essentially correspond to like a certain socioeconomic group or something like that, you can accidentally reinforce, socioeconomic divisions in our society simply by having a model that's using your existing bias to further, reproduce that bias going forward. And that feedback loop can be really dangerous for society, especially when you think of the climate right now. We have a lot of people that essentially are under a lot of pressure from a system that's, working against them. And so having algorithms also working against them doesn't really allow them a whole lot of measures for recourse. So we really don't want these machine learning models to become black boxes that can't be questioned, because if that happens, then how do you know it even made a fair decision? And if it made an unfair decision, how do you contest it in like a court of law?
Yeah, I recently heard about I wish I could remember the name of the group, but there's a group out there that is using AI to actually detect those biases, as far as wage discrimination and police discrimination and things like that. Is I would assume it is possible, but do you think it's possible that that AI could also suffer its own confirmation bias and make it seem worse than it really is? Or
Potentially. I think this is where, the data science and artificial intelligence really play well together. If you build an AI model, a machine learning model that's essentially making a prediction of some kind, and you just use it assuming that it's always making the correct decision without any understanding of the underlying statistics or the long-term implications of the decisions it's making, you can get yourself in a lot of trouble and not even realize you're doing it. But if you have data science acting as kind of a checks and balances, you can do statistical analysis to see, hey, are these models actually producing decisions that are biased in a specific way or will lead to some kind of long-term negative consequence that we hadn't really seen in advance. And so I think that the two play very well together. And when you pull them apart and you don't have them checking and balancing one another is where you end up in areas that can be potentially dangerous, where you might shoot yourself in the foot because you don't know enough about how the AI is actually making a decision to prevent it from making incorrect decisions or long-term negative consequences. And this is why, it's very important that we invest the right amount of time in understanding what's going on under the hood with these machine learning models, and why I recommend to my clients and to the people that I teach, always use the simplest model that effectively solves a problem. If you can use a deep neural network to detect fraud, but if you can solve the same problem with something like a decision tree classifier, it's going to be way easier to explain to others why it made the decision it did. And if you ever have to go into a court of law to, say, well, why did you discriminate against this person? You can say, here's exactly why the machine made the decision that it did. Whereas if it's a giant deep neural network without some kind of explainable AI component, you have no idea. And good luck explaining to a judge, how the trillions of, linear algebra calculations and backpropagation led to it producing the result that it did.
Yeah. Are we getting to the point where those complex neural networks that are needed for larger decisions, are we getting to the point that they can actually explain how they arrived at those results? Or
yeah, explainable AI is a relatively new kind of area of research, or at least it's becoming a bit more mainstream as people recognize the need for this. There's certain techniques we can use in order to I don't know if it's right to say to teach the model how to explain what it's doing, but for example, if you were trying to detect breast cancer, you'd feed a bunch of images of mammograms into the algorithm, and it would then make a prediction as to whether somebody has breast cancer or not, and just give you a number, the likelihood that what I'm seeing in this image is cancer or not. But what you can also do is you could feed in a doctor's explanation in text with each of those images saying why the doctor said that this image contains breast cancer. And through a combination of the image processing and the natural language processing, the model essentially learns not only to make a prediction about what the likelihood is that there's cancer, but formulates a sentence in English explaining why it believes that's the case. And now there's a lot of magic happening in there, but at least you're getting something that's a plausible English explanation as to why that decision was made. And that's, better than having nothing. But there's also more advanced things we'll eventually be able to do in terms of diagnostics to look at the model and see, was there something that led it astray in this direction or not, that we can then correct in the future. So it's a pretty active area of research right now. And I think we're going to see a lot of really powerful stuff come out, especially as the issues with using these models without any kind of explanation becomes more important.
Well, I think the scenario that you just described is probably, to me, one of the best uses of AI, taking an error-prone process that's really relying on the judgment of the doctor and reducing it down to a quantitative decision being made, especially if the AI can explain why it made that decision. I would hope that we would get that good enough that it could greatly reduce the error rate and save a whole bunch of lives.
Yeah, I think so in one case, these machines will eventually get better than any human doctor at doing certain kinds of diagnoses. For example, the machines are currently better at diagnosing microfractures, which are very difficult to see in x-rays. They can do certain types of brain cancer diagnostics where they're not just looking at a single image at a time like a human doctor does. They're looking at all of the data in all of the slices and all of the densities at the same time to see correlations across the dimensions of data, something a human doctor just simply can't do because they can't visualize a two-dimensional chart in four-dimensional space as they're looking at both 3 dimensions and the density, the slices of density. And so, they'll get better than human doctors in certain categories, but I don't think we're going to see that, the human doctors just disappear, at least not overnight. And that's because when you pair a human doctor with an AI, you end up with something that's even more powerful than just an AI or a doctor alone. And I think that's what we're going to see, at least in the transitionary period, where these AI and doctors will, essentially look at the same data and they'll make a decision. And if the AI and the doctor agree with one another, then they'll move forward with the procedure. And if the AI and the doctor disagree, they'll probably pull in another doctor who doesn't know what decision the AI or the human doctor made to act as a tiebreaker in this scenario, so that you're essentially acting as a checks and balances for these AI processes. And I think that that type of situation is what we're going to see happen, at least in the medical industry in the near future. You won't just eliminate doctors overnight. But at some point in time, when we get to a level of general AI, then even doctors may not be necessary.
Yeah, it's good to hear the level of detail being fed into these systems and the thought being used to devise these systems. Because I can imagine feeding a collection of two-dimensional images to AI and coming out with people with tattoos have cancer or something ridiculous like that, without truly understanding that there's so much more data and information being fed into the systems. Now, I grew up largely on television and movies, so I have a great want and need for like a utopian kind of Star Trek world where we're all benefiting from advanced computer networks and things like that. But I also have seen Terminator and fear Skynet. So I much would prefer a utopian type society of Star Trek, but how do we get there without being in danger of releasing Skynet into the world? Are there checks and balances in place? Do we need to be aware of the types of problems that we might incur or develop ourselves?
Well, in the short term, we've got a lot of potential issues that we're going to have to deal with, and they largely revolve around humanity and conflict with technology in terms of things like democracy. How does democracy function in a world where you've got constant and pervasive surveillance and the ability to manipulate people? And, and things beyond that, like, I probably won't go into that, but going very far down in the future, there's really only 3 paths forward for humanity and our technology. Either humanity and technology, our AI, peacefully coexist forever, or we end up accidentally destroying ourselves first, or the AI essentially displaces us, making us obsolete, like in the Terminator scenario, or we essentially merge with our technology in such a way that humanity and technology are indistinguishable for one another. So the first scenario, that we peacefully coexist, doesn't seem very likely. If you look at historical, scenarios, sufficiently advanced civilizations always seem to displace the indigenous population. We've just seen it time and time happen again. And so I don't think we'll peacefully coexist with AI forever, unless it stays relegated to essentially being the ship's computer and not, competing with us directly in I don't know, the kind of general AI tasks. The other possibility that we destroy ourselves first, or AI essentially displaces us, probably a lot more likely in the long run, but not very good for us if that happens. So the most hopeful and likely of the outcomes is that we essentially merge with our technology in such a way that there really is no distinction between AI and human. And now this sounds really far-fetched when you're just thinking about it today, but I mean, the cell phones in our hands are already an extension of our brain. And the next generation is essentially ready and willing to have that technology directly connected to their minds if and when it becomes available. And in the very, within the next 10 years, based on what I'm seeing, we're going to be augmenting with, augmented reality glasses that will just look like a regular set of glasses. And, we've already got our earbuds in and, wearable devices on us. So we're already augmenting our human bodies with a lot of technology. And it will eventually get to the point, where we'll have brain-computer interfaces. That doesn't seem like it's unrealistic anymore, that we'll see brain-computer interfaces in another 20, 30 years or something like that. And at that point in time, we're not that far away from essentially just being one and the same with our technology. But that's the way we essentially get out of destroying ourselves with the technology or the technology destroying us, is that, if you're the same thing as the technology, then there's nothing really to destroy.
So the best hope for our future is to become the Borg.
Yeah, it sounds pessimistic when you put it that way, but let's hope it's a bit more Star Trek like than Borg like.
I'll just integrate with the technology. Resistance is futile and all that.
That's true.
I would hope that, for the most part, AI sticks to kind of the narrow field and it's specialized to do one thing. And in the cases where we do use general AI, that it's, I don't know, maybe not smart enough to realize that it's better than us.
Yeah, so the main problem with this is that once we hit artificial general intelligence without some pretty significant constraints on it, it has the ability to iteratively self-improve, which leads to what we call artificial superintelligence very fast. And artificial superintelligence has no biological constraints like the human mind does. So its ability to improve itself and to think in ways that humans couldn't even possibly conceive of thinking, and to think many steps ahead of us, means that we would just have no ability to compete with this thing if and when it does reach a level of superintelligence.
Well, thankfully, that's at least a few years off.
Yeah, we got a little bit of time yet. We got some other issues we have to deal with right now, anyways.
Yeah. So before we get there, in the presentation that you have on YouTube, you mention the risk to certain careers, jobs. As developers, is our job at risk? What do we need to do to prepare ourselves for this AI future?
Well, in looking at the entire landscape of labor, we know that there are some jobs that are going to be relatively easy to automate. When you think about the jobs we've already automated, they had very similar properties about them. They're repetitious, they're low complexity, they're dangerous enough that the cost, to life is high enough that it's worth investing in. And a few other aspects as well, too. So you can start to see a profile of jobs that will be easy to automate as the technology becomes there, because it's all driven by economics. And then we see jobs that are more difficult to automate. So jobs that require creativity, compassion, empathy, establishing trust. Once again, this is why it's unlikely the doctors will disappear anytime soon, because if a human doesn't trust the AI, they trust the doctor, who can essentially establish that trust and explain to them and be compassionate and understanding. So we're going to see a large subset of jobs in the middle, though, that will not entirely be automated. But a lot of the monotonous mechanical aspects of the job will be automated. And so I think software developers fall in kind of that middle space as well, where there's going to be certain things that we do as developers that will just kind of almost disappear overnight, but it'll be a tool that essentially replaces it. Like, think about IntelliSense. A few years ago, if you would have shown a developer IntelliSense, it would have blown their mind. Like, the idea that the machine could predict what I was going to type, like, that's crazy. And now we've got, like, with the Turing, Microsoft's Turing NLG model, and once again with GPT-3, this ability for it to predict not just the next word we're going to type, but the entire block of code based on all of the code we've typed before that. And so, we're going to feel like we've got superpowers as software developers, and that's essentially just going to make one software developer significantly more effective or efficient or powerful than we were just a few years ago. And even tasks like right now, regular expressions, this is what I'm just waiting for it to be automated. Every software developer I know hates writing regular expressions, but we have tools now that you can feed in the input data and what you want it to look like, or what you want to capture from it, and you just give it a few examples, and it can build or synthesize the regular expression from those input output pairs. And we can do the same thing with data transformations now too, where here's what the data looks like, here's what I want it to look like, give it enough examples, it synthesizes a model, and anytime you see an outlier, you just give it that, the correction to it, and it builds that model. So like, this is something that a software developer might have spent like days building a data transformation pipeline, and now it's essentially just, here's the input, here's the output, give it enough examples, and then give it additional examples when it doesn't behave how you want it to. And so as software developers, I think a lot of the things that we do in our job are going to disappear. But I hate to say it, most of them are things we really don't want to be doing as software developers anyways. And even things in terms of like UI design. We now have tools that can essentially reverse engineer. You take a picture of what you want your screen layout to look like, and it'll essentially synthesize the HTML for that layout based upon either your drawing or the screenshot you took of someone else's website that had a nice layout or look to it. So a lot of things that were difficult to do will essentially be automated away. But I think software developers are still going to be around for quite a while, because most companies are going to still want a human being in that pipeline or that loop somewhere. But I think our jobs are going to become more about managing software and tools and babysitting essentially algorithms than it will be about the kind of pure creative flow of writing code. We'll be solving these problems. We just won't be using the same set of tools or solving them in the same way that we did.
Where do you get that last tool that you mentioned? They can take a pic. They can make a website for you.
Oh, I'd have to look that up, but we can find it and put it in the show notes.
I would love to have that at my disposal.
Yeah, it seems like the last 10 years or so has been spent automating all of the boring, mundane tasks. So we've got build and release pipelines, we've got test automation and unit tests and UI tests and everything on under the sun in that genre. So we've automated all the mundane. It sounds like now it's automating the difficult and predicting the next steps is kind of the next logical iteration.
Yeah, and I think that's how we're going to see this technology evolve in pretty much not just software developer space, but in all occupations. We'll continue to automate the things that make sense economically. And it's, is it a simple task? Is it repetitious? Is it monotonous? Is it, high risk? Is it error prone? Is it dangerous? Like all of these factors that, add to the cost half of the equation. And then we just essentially look at the value proposition. Well, how much money would we save if we automated the build pipeline instead of having Bill have to push the button at night, to release or to go through the manual steps or process. And we'll do that with all of these different occupations, and pieces of jobs will disappear, but you're not just going to see, whole classes of jobs disappear overnight. Like even, fully autonomous semis, which I think is going to be one of the biggest shocks to our economy when this happens, is still going to have human drivers in the semis for quite a while. But once again, their job is going to be changing from driving the semi to essentially managing the software and babysitting the semi, the machine itself.
So, in preparing for AI, how do we go about educating ourselves in the proper way for the future?
Well, it comes down to a few different things. I think first, there's a basic level of AI literacy that everyone in society needs to have in order to function in the new world. Same thing with the previous technology revolutions. Like if you, before the automobile, if you didn't understand that walking out into the street with an automobile was a dangerous thing, you probably wouldn't last very long. And we're going to have the same kind of situation with artificial intelligence. Like everyone in society is going to have a basic level of understanding of how this stuff works in order to function in the world. You won't need to know how the internal combustion engines from the ground up, in the same way you won't need to learn how a deep neural network functions from the ground up. But you do need to understand things like if I push on the accelerator, it goes. If I push on the brake, it stops. Like that kind of level of knowledge from the outside. And then beyond that, you need to figure out how you actually want to use AI. Like what is your objective? So are you planning on training AI models for your company? Do you just want to build applications with pre-built AI models? Or do you just want to use these tools in order to become more effective at your day-to-day job? So depending upon which path you choose for your career, there's various learning paths or curriculums that are ideal for what you're trying to do. So for example, if you want to learn how to train AI models, you're going to need to understand machine learning, and you're going to need to understand data science as well. And if you want to, develop AI applications, you're going to have to understand programming and how these third-party AI models work. But if you just want to use AI to improve, your overall productivity and efficiency, you won't require anything other than basic, AI literacy plus the knowledge of how to use those specific tools in your specific job. And beyond that, it's just practice. Doing this stuff. It's one thing to know what a neural network is, but it's a very different thing to know how to use a neural network to detect fraud. And so, without actually practicing these things on a daily basis, you won't, be able to use them in production and stuff like that. And, make sure you're choosing reliable sources for all of your education. There's a lot of people out there that are essentially trying to jump on the buzz and the hype bandwagon, and they're just doing it to try taking your money. But there are a lot of really good organizations out there that are essentially teaching you what you need to know from reliable teachers that have the right credentials, expertise, and background to do so.
With that, do you have any preferred resources that you can recommend to us?
Well, I always like to recommend my website, but my website, I have tons of free articles and videos. I've got a free course on this topic specifically that I should have finished by the end of this month. So by July 1st, there should be the Preparing Your Career for AI course on my website. And then I teach a lot of courses on Pluralsight. So if you're a software developer, an IT professional, and you just want to learn how to use specific technologies, at work the next day, that's a great place to go for that kind of education or information. If you're just starting out, you don't have any programming experience, and you've got a long way to go, there are probably better resources in terms of academic knowledge. But if you want to invest the time and money to go back to college and study machine learning and AI from the ground up, by all means, that's what I did. But for a lot of people, they just need to figure out, how do I use this computer vision feature to classify this image so that I can make the rest of my application do what it needs to do. And for that kind of stuff, you don't have to go back to college for that. We're to a point now where so many of these AI tools are so easy to program for a software developer. And so I don't know what the right word is, but you don't have to understand how they work from the inside out in order to get good, reliable results from them. That we're now at kind of a turning point in the industry where you don't have to have a data scientist in order to solve a specific problem. You just feed the data into AutoML, and it essentially produces the best model given the data it's seen. Or probably a more realistic scenario is you've got, like, say, for example, product detection. So you've got like a Twitter feed, and you just need to figure out any image in your news feed that contains your company's product or logo, and you just want to flag it. Like, that's something you can now do without any machine learning experience. You essentially just take a pre-trained model, you use transfer learning on it. So essentially you're just, you're feeding it a couple examples of your logo, and then you code the input from the Twitter feed using a REST API with any programming language. Don't even need to know R or Python. You can do it with any language you want. And then it's going to spit out a prediction. What is the statistical likelihood that this image contains your company's logo? And if it's above that certain threshold, then you kick it out to the, wherever the image is going. And if it doesn't, if it's lower than the threshold, then you don't. So we're at a really interesting time for software developers to be getting into this, into the AI space right now in ways that you just couldn't have done, even a few years ago.
One of the things that we like to ask all of our guests is for them to provide some of the wisdom that they've gathered over the years to new developers just getting started, or developers that maybe have been developing for a while but are looking for a way to level up their career. What might you say to those individuals?
I think for me, making an investment in your education, your career is probably the smartest thing you can do right now. The best software developers I've ever met, and the ones since this is a six-figure developer, the ones that are all making six figures are all people that seem to enjoy learning. And not just enjoy learning, they have a desire to continue staying up to date and learning new things. And not just learning the right things, but also learning what things not to do. Like, you can be in software architecture and have this, great idea for, a piece of software or an architecture for software. But if you haven't seen all of the ways that it can fail, you don't know what the alternatives are, and you can essentially paint yourself in a corner. And I've seen that happen time and time again. So invest in your education and invest in your career. Make sure you're working for somebody who truly values you as a human being, not just a resource, and is willing to invest in you and your development as well. Because there's a lot of really good companies out there, and there are even more companies that are not great in the way that they treat software developers. And for me, if you're someone that's on the verge of making a career switch, historically, every time I have made that career switch has been a positive result. I have never regretted switching companies when I finally made that decision. And the turning point for me almost every time was that I was no longer learning. Like if I was in a job or position where I didn't feel like I was learning something new every day, that was my clue to move on. And every time I did, it was the right thing to do. So yeah, just be investing in your own education and your career path going forward. I think that's probably the best thing you can be doing right now. Oh, and one thing that I always like to advocate is mindfulness. So in the IT industry, we are dealing with a lot of mental health issues. Like we are specifically predisposed as IT professionals and software developers to certain types of mental health issues. And it has a lot to do, we think, with the conflict between human nature and our technology. We weren't designed to have things beeping at us all day long, and we weren't designed to have Reddit, pulling our attention away, or your Twitter feeds essentially pulling our attention. And that conflict between our technology and human nature is essentially leading to a lot of problems that, for the most part, are preventable. And the way we prevent that or manage these issues is with mindfulness practices. So things like meditation and yoga, good exercise and stuff like that. Essentially, we can train our brains to be more resilient in this world filled with technology and distractions and a lot of negative stimulus.
Excellent advice. Thank you.
Yep, I meditate every day, usually about 30 minutes in the morning.
I used to do some meditation. I kind of stopped. Probably should get back into it.
Yeah, now's a great time to be, increasing our daily meditation.
Yeah. So if anybody wanted to reach out to you to maybe get some more information about AI, do you have any social media accounts that they could use to contact you?
Yeah, the best way to get a hold of me is typically through my website. I have links to every social media account that I'm active on the website, and also a form you can fill out if you just want to send a quick message. But I encourage you to engage with me. Send me tweets on social media or ask questions. I've also got discussion forums for all the courses that I have, so I get a lot of questions about the very specific topics from people that are watching those courses as well. So MatthewRenze.com is where you find me. I'm also on Twitter, and I'm on LinkedIn as well.
All right. Thanks, Matthew. Really appreciate you taking the time to speak with us today.
Thank you for having me.
That was Matthew Renze. Matthew is a data science consultant, author, and international public speaker. He has over 2 decades of professional experience working with tech startups to Fortune 500 companies. His current focus is on teaching others data science, code craftsmanship, and Agile software development.
If you like this episode, please like, rate, and review on iTunes.
Find show notes, blog posts, and more at sixfiguredev.com.
And catch us live each week on Twitch, and be sure to follow us on Twitter at sixfiguredev.
This has been another episode of the Six Figure Developer Podcast, helping others reach their potential. I am John Calloway.
And I'm Clayton Hunt.